Alright, how we doing, folks? This is Jeremy with 603 Drones LLC up here in Goffstown, New Hampshire. Wanted to do a little demonstration video for you all today on how we are hooking up a Flir Vue Pro thermal sensor to ride piggyback on the DJI Inspire 1 to allow us to capture thermal data at the same time that we're also capturing standard RGB data through our Zenmuse X5 with whatever particular lens we happen to be carrying on it for that mission. So this is a very easy setup. It's non-gimbaled. It's very important to keep in mind. If you are looking for a gimbaled option, then there are a number of aftermarket gimbals that are available for the Vue Pro, but keep in mind that most of those options are going to prevent you from being able to ride with your standard RGB imaging. And of course, if RGB imaging and thermal data capture gimbaled together are critical for you, then you're going to want to look into a different type of a package that can carry both a thermal and RGB camera on separate gimbals, something like the M600, the M210 RTK, something along those lines. So let's get started. So the basis for this setup is, of course, the Flir Vue Pro sensor. For our purposes, we tend to use the 640 13mm 30 megahertz version of this. This is the non-radiometric version, so this does not capture your temperature data within each pixel the way that the radiometric version does. But for what we do, most of the thermal analysis that we get called on to perform does not require that level of accuracy. So this sensor allows us to save a little bit of money on the upfront cost while still being able to deliver the type of data that our clients need. So the 640 actually comes with, and just want to clear up that I'm not doing a video here on the thermal sensor itself. So if you're looking for more data on what the thermal sensor is, its capabilities and specs, etc., there are plenty of those type of videos on YouTube, including directly from Flir themselves. So the thermal sensor comes with a standard GoPro mount. They call it an action camera mount because, of course, copyright prevents them from using the word GoPro, but it is a GoPro mount. So that GoPro mount just slips right over the lens and allows you to use any variety of GoPro mount that you want for whatever your purposes are. In order to get video transmitted down to a monitor from this, there's a few things that you need. You need a wireless video transmitter. This particular one right here is the DJI AVL58. See if I can get you a little bit better shot there. There we go. The AVL58 is a decent wireless transmitter, not particularly expensive. I want to say it's in the ballpark of about $50 or so, but don't quote me on that. You can find them on Amazon. The other option is to use the very popular ImmersionRC 600 milliwatt wireless transmitter. This one is pretty well known for its use amongst the FPV crowd, the first-person view flying crowd. I know a lot of RC car owners use it as well. It's a very good transmitter. It's got a good range. We've actually come to prefer this one over the AVL58. Just seems to be a little bit more reliable. We get less interference with the DJI units when we fly with this one. So it's just something that we prefer, but you can of course try out whichever ones that you think would work best for your application. So the ImmersionRC is great because it comes with two wiring harnesses. It comes with a 5-wire harness for your audio and video power and output circuits, and of course it comes with just a standard 2-wire harness for power and ground to the unit itself. So all you have to do to splice this in and make it work for your thermal sensor is get rid of the 3 wires that you see here that we're not using. Let's see if I can get you a good view here. The green, the white, and the red are not required because they relate to audio and then a power signal that isn't needed for what we're doing. And that leaves you with the yellow and the black, which are your video positive and negative wires, your signal wires. You're going to splice those into the USB cable that plugs into the side of the thermal sensor, and that USB cable should have at a minimum 4 wires because you need to have a power, of course, a ground, and then of course you need a video power and video ground as well. So I'm not going to get too hung up on colors because every USB cable comes with its own, you know, set of color schematics depending on what you buy. The important thing for you to understand is that coming out of the wireless transmitter, you want to have your yellow, which is your video feed, connected to the video positive of the USB cable. And of course your black, which is the video ground, you want to make sure that's connected to whichever wire is identified as the video ground on your USB. Okay? For your standard power, and by the way, that's it. It literally is as simple as that for getting video. It is just those two wires connected to the two wires of the USB cable. Okay? For your standard power, it's pretty simple. You've got positive and negative coming out of the transmitter, which would actually, I'm sorry, would be going into the transmitter in this case. And then you have positive and negative power that you need for the USB cable going into the thermal sensor, because of course you need to be able to power it on. The problem with Flir Vue Pro sensors is that they are limited to an input voltage of just over 5 volts. They say 6 volts max, but I really wouldn't say go much over 5 volts. But most of your aftermarket batteries tend to be more around the 7 volt range. So you need to step that down. How do you step that down? Easy. You just get a UBEC. This is a mini voltage regulator. This particular one is made by a company called Hobbywing. And all you're going to do, follow the steps here because it's really, really simple, is you're going to start with a battery cable. Okay, this end here plugs into your battery. You're going to splice that into the input wires of your voltage regulator, which is then going to come out, and you're going to take the 2 wires from the voltage regulator and you're going to share the splicing with the USB cable and the wireless transmitter. So that way you are supplying, and I hope this video is showing enough detail here, but that way you are supplying power to the USB cable and the wireless transmitter at the same time. That power, again, will be coming from a battery, which we'll show off in a minute here. So that's it. It's a pretty simple wiring setup. This unit that we have here that I'm holding in my hands, this was one of our early units, but we still use it, ugly as it is, because it works beautifully, so there's no reason not to use it, and I'm just not going to waste time beautifying it because there's no need. For most of our units now, we're using this type of USB cable, which you can get on eBay, and I will provide a link for in the information for this video. It's a much more low profile USB, so instead of having your straight input, which we did for our test setup, you instead have a much lower profile 90-degree wire harness, so just makes things a lot cleaner looking. But as you can see, it is a 4-lead, 1, 2, 3, 4. It is a 4-lead wiring harness. So this is perfect for what we need for the Vue Pro. And incidentally, you can also do this exact same setup on a standard Gopro camera if you wanted to do something along the lines of first-person view with a GoPro. So I also want to take a moment now to illustrate that the wire colors on this unit are different than the wire colors that were on the USB cable that we used for our initial test setup. So again, I just want to stress, make sure you identify which wire is which before you start splicing things in, because the last thing you want to do with a $3,000 or $4,000 or $5,000 thermal sensor is blow the circuitry inside because you plug something in wrong. So check, triple check before you apply power. Okay, so now let's go through the process of actually applying power to the thermal sensor. Again, as I just said a moment ago, you have checked, triple checked everything before you're doing this step to make sure that you don't have your wires crossed anywhere and you're not going to short out your unit. That would be a very costly mistake that would not be covered under warranty, so I cannot stress it enough. For our purposes, we have found the Fat Shark 7.4 volt 1800 milliamp hour battery to be the best solution. Okay, let me see if I can pull this into focus here. There we go. So this is a very standard battery. A lot of good reviews that you'll find if you look it up on Amazon and eBay. Pretty inexpensive. Again, I'm happy to provide a link for it in the info to this video so that you can shoot straight for it on Amazon. But it is a 7.4 volt battery, so we use the UBEC to step it down to the required input voltage for the Flir Vue. And we've made no modifications to the battery. So very important, no modifications necessary. In order to splice it in, one thing that I neglected to show a moment ago was this is the headset banana cables that we use. This is also a Fat Shark product, as you can see right here. I don't know if that label's going to come into focus for me or not here. There we go. This is a charger adapter that they use for their headsets, but it's simply a pair of banana plugs with your input. And all we do is we chop off those two banana plugs and we splice the ends into the UBEC that we showed you a moment ago. Okay, so putting all this together is very simple. We have our UBEC that we attach via a Velcro strip to the top of the sensor. Then we take our wireless transmitter and we Velcro that to the bottom of the sensor like so. Okay, easy peasy. USB cable into the side. So very elementary. Okay, this is your rubber lens cover that Flir provides with the Flir Vue. So we take that off, there's your lens, and then actually I want to use this unit here. Let me just take this off real quick. Okay, and then it is as simple as applying power, like so. And now you have everything set and ready to go. One important note that I forgot to mention earlier, this is extremely important. Do not apply power to the wireless transmitter unless you have an antenna plugged in. That is a very important step. When you read through the manual for the wireless transmitter, for any wireless transmitter, you will find that exact same verbiage. Do not ever apply power unless you have the antenna plugged in. Okay, where does the signal go? For our purposes, we use a Flysight Black Pearl monitor. These monitors are inexpensive. I think brand new. They run us about $140 a piece. You can find used ones online very easily for pretty cheap money. So they're a good, rugged, durable, all-around use diversity receiver. And because they are a diversity receiver, they are capable of receiving up to, I believe, 32 channels of wireless signal. We only use one that we keep it on nonstop, so it works, again, really well for our purposes. The sensor is on, power on the Black Pearl monitor, and as you can see right away, we have a signal come up. So that's what we receive our signal on. How do we control that signal? You're going to need, on your cell phone, a app from Flir called Flir UAS. And if you can see it right there, Flir UAS, open up that app and your phone will be connected to the Vue Pro via your Bluetooth. So the first time you use this, you might have to go through the Bluetooth pairing process, but every time after that it should pop up right there on your phone as soon as the Vue Pro is powered on. Once it comes up, select it. You'll see that it takes a moment to connect. You can see a blue line here, kind of, I'm not sure if you can see it or not. It might be too washed out on the video, but regardless, here it is. So the Flir Vue Pro app allows you the ability to do anything that you need with the sensor in terms of changing the color palette, setting what type of image capture you want, whether you want video, timed video, every few seconds video, or just one, or excuse me, stills, or just one still at a time. So all that is done within the app. I'm going to change the color palette right now just because this is going to give us something that's probably a little easier to see on video. So let me set it to lava, and that way, as I'm showing off the Flysight here. Well, that one actually doesn't work too well either, does it? Alright, hold on one second. Let me see if I can get something here that looks a little bit easier to see. Just to show, you know, again, how the sensor is working. You know, there I am. Okay. Anyways, I'm not, again, showing off the sensor. I'm just showing you how to make it work. So I think you get the point. It works. So let's move on from here to attaching it to your craft. And that's what we'll get into in the next part. Okay, now that we have everything wired up, we've applied power, how do we attach it to the DJI Inspire 1, which is the ultimate goal of this setup? Very easily. On the back of the Inspire 1, let's see if I can show you this here, you have a little bit of a flat area right underneath the battery encasement. On that battery encasement, we have installed a standard GoPro base mount. See if I can get you a good view of that there. There you go. So that is just a standard base mount provided, you know, for GoPro cameras. We've attached it with adhesive, but as a secondary measure, we have also zip tied that to the bottom of the encasement with small zip ties. And the reason for that is because we just, of course, don't want to take any chances of the adhesive letting go and our very expensive sensor falling off. Now, a note on the zip ties. If you use zip ties that are too thick, your battery will not fully seat into its emplacement, and that's going to cause you problems while you're flying, especially if it jostles just enough to lose connection. So when you're zip tying the base mount, if you choose to do so, make sure that you're using ones that are small enough that they do not in any way impede the ability of the battery to seat into its connector. Okay. We use this particular set of headlights for our Inspire, and we've been using these since long before we got into thermal. So when we installed these, we put the battery for them right onto the back of the aircraft's battery encasement. A lot of folks who ride thermal sensors piggyback the way that we do will put their battery in that location for their thermal sensor. Because we are unable to do that because of how we have our headlights, we actually have an alternative placement for our battery, which I'll show you in just a moment. And there's no rhyme or reason. It really doesn't matter which way you do it. You know, whatever works best for your setup. Okay, so mounting it directly to the aircraft, and I had to do a quick little cut there just because it wasn't working the way I needed it to. Again, this is all standard GoPro equipment. This is just a simple mount bolt that comes with any GoPro mounting package. So we're going to take our sensor and slip it up into the mount. This, of course, just slides right in. And you just screw it in, like so. Now, it is the tension of this bolt that allows you to determine which angle you want the sensor to be carried at. So for most of the work that we do, we're running at either a 90-degree angle down or a 45-degree angle forward facing. So just a matter of loosening up that mounting bolt and then angling it however you need, like so, and that allows you to get the angle that you need. Important note, I have the antenna facing up right now just because I'm working on the bench, and that allows me a little more room to play around, but you're going to want that antenna facing down when you're actually in flight operations, just so that it gets the best signal direction to the receiving unit. Battery for us, again, most folks will mount the battery to the back here via Velcro. We have something in its place already, so we tend to mount the battery right here. And then I have a little Velcro strap that I use that keeps that in place just in case the Velcro between the airframe and the battery fails. So one of the things that you'll note in all of my mounting discussion here is redundancy, redundancy, redundancy. Zip ties, Velcro straps, whatever you can use to ensure that your very expensive components are not going to fall off mid-flight. Always do so, especially if you're relying on adhesive. We're up here in New Hampshire, so we have 4 seasons worth of flight weather, and adhesive reacts differently to every type of temperature. So, you know, again, redundancy in your mounting is always good. So that is it. Everything's on. We have our Black Pearl diversity receiver getting the signal, and all we do now is take off and fly. It's as simple as that. With this setup as it is right now, important note, very important note, you do need to set your color palette and begin the process of taking photos before you leave the ground. The Bluetooth connection to your phone is only good for about 15 feet, and then after that you just drop right out. So you're not going to be able to capture pictures on demand while it's in the air. What you're going to want to do on your app if you need stills is you're going to want to select the intervalometer, that setting, which allows you to set, you know, however many seconds that you want it to take a picture every 5 seconds, 15 seconds, whatever it may be, and then start that before you leave the ground. Or if you're doing video, start the video before you leave the ground, and then just edit out the unnecessary data before you deliver the video to your client. I'm going to go over in just a moment here an additional option for control from the ground while the unit is in the air via a Futaba radio controller. So I'm going to get that set up, and then I'll show you that, and we'll end this long video with that. Okay, so it's a little clunky trying to control your thermal sensor from the ground when all you can do is start and stop the video via your cell phone Bluetooth signal. You gotta plan for the data that you're wanting to capture. You've got to change the color palette from the ground. You've got to start the data capture process before you even leave the ground, and then that's it. And once you get up in the air, if you realize, you know, this color palette just isn't showing me what I need, or the client maybe is working alongside you and says, hey, can you capture some video as well, or whatever the case may be, you just want to have control from the ground to the extent possible. And one of the ways that you can do that is through a separate radio at the ground level. So you of course are already using your DJI or whatever other brand of aircraft you're using. You're already using the radio receiver to control the aircraft, so your hands are going to be full. But if you have someone working alongside you, or maybe you have a platformed ground station set up, which is what we use, where you have a little bench mounted on top of a tripod and all of your controls are right on that bench, then it's easy enough to throw a second controller in the mix. And what we use is the Futaba T8J. It's a very inexpensive radio controller from Futaba. You do not need to go out and buy a radio controller that has all the bells and whistles for flying an aircraft, because we're only going to be using 2 switches off of this entire deal, for this purpose anyway. So with the T8J, when you buy it, comes the receiver that you mount to your aircraft. So this receiver with its antennas, you would mount somewhere in an open area on the aircraft that doesn't interfere with props or the battery or anything else like that. Of course, make sure it doesn't interfere with the legs being able to go up and down. The Vue Pro sensor is supplied with a wire harness specifically for connection to an aerial flight controller. This is really nice stuff that Flir has added into this package. So this wiring harness has the ability to have, you can actually see by the labels, you have telemetry data. If you have a Pixhawk controller that you're using on a custom-built Hex or something along those lines, then you have the ability to send that telemetry data. You have PWM3 and PWM4 as the other wires. And the PWM3 and 4 are what we're going to be interested in here, because we're going to connect those to the Futaba receiver. And for my purposes, I'm using channels 5 and 6, but that's because of the buttons that I want to use on the receiver. You use whichever channels you want that correlate best with what you want to do on your radio. And then this harness here is, of course, again, just simple power and ground, and that plugs into its own socket, slot 8 on the receiver. Okay, the transmitter I have set up so that, again, channels 5 and 6, which are what I have the PWM cables plugged into, are right there. And I have it set to be able to control the color palette as well as the start and stop data capture on the sensor. And that to me is important because it enables me to switch between color palettes, the three color palettes that I use the most when flying in the air, which are the white hot, the lava, and the green. And those are the three that really shows us the most range of information when we're doing the different types of work we do. So if I needed to change it up and put a different one in there, that's easy enough to do via the Flir Vue app. So I'm going to get this thing connected and then show you exactly how we use it. Okay, so we've got the receiver hooked up to the aircraft. We have the radio transmitter, of course, sitting on the desk here. I have the channels 5 and 6 on the radio selected for color palette change and data capture start and stop, as I mentioned earlier. One thing I do need to do super quick here. Let me just set the sound. I want to turn the sound on the sensor when data begins being started and stopped. The reason for that is because you won't know that it's taking place otherwise. Because this is for demonstration purposes, I don't have any of the wiring cleaned up, and I'm not trying to show you precisely how to do this with your aircraft because your setup is going to be slightly different in some ways. So you'll have to use your imagination on how you want to set everything up. But the nice thing about these Fat Shark batteries is that they have an additional power supply that is used. Now, I don't own Fat Shark FPV goggles, so I'm not going to claim to know what that additional supply is for. I have no idea. What I do know is that it's perfect for these purposes because it allows us to plug in our receiver directly to the battery without having to have an additional power source. And this draws such a small amount of current that it does not in any way degrade your battery use for the sensor. So that's an important point, and it's nice to have. So looking at the Flysight, at the Black Pearl, I mentioned that we can change our color palette using the radio, and I do that with my 3-channel switch because I have 3 different palettes programmed. So down changes it to lava, middle keeps it in my green, and up changes it to my white hot. Again, these are the 3 palettes that work best for our purposes. But if you need to change them, you can do that in the app, and that's easy enough to do. The second switch that I use here, which is my 2-position switch, and actually I don't need the monitor for that, so let me make this a little less awkward. My 2-position switch is simply data capture, start and stop. Listen for the beep. So that was taking a single picture. There was another picture. Okay, so it's literally just a throw up and a throw down. Now, if I set for video via the app and I want to start the video after I'm already flying, then again, yeah, that double beep was indicating that video has begun. And that triple beep indicating that video has stopped. So it's a great tool to use for having just a little bit more control over the sensor while it is in flight without having to set everything up from the ground. Okay, so that concludes our demonstration of how to hook up a modular Flir Vue Pro thermal sensor to a DJI Inspire 1 aircraft. I hope this was beneficial. I know it was really long and detailed, so thank you for watching. Remember that most of what you've seen here can be used on a variety of different aircraft. This is not unique to the DJI Inspire 1. This just happens to be the aircraft that we fly the most. All right, again, Jeremy, 603 Drones LLC, 603drones.com. Thanks for watching.